Hi, my name is 𝐂𝐶𝐬𝐢𝐧𝐿 and today we'll be talking about how to interpret the DP profile in an HPLC analysis report. Before we dive into the data, let's understand why we use the concept of degree of polymerization or DP in the first place. In ethanol production from grains like rice and maize, the starch must be broken down into simpler sugars before yeast can ferment them. We track this conversion using DP levels. DP4 plus is starch, which consists of long and branched chains of glucose. DP3 is maltotriose, DP2 is maltose, DP1 is glucose. Our goal is to break them down, all of it into DP1 for efficient ethanol production. In grain to ethanol process, during liquefaction, alpha amylase breaks the starch, which is DP4, into dextrins, which are DP2 and DP3. Then, during simultaneous saccharification and fermentation, glucoamylase converts these into glucose, which is DP1. Yeast consumes DP1 to produce ethanol, glycerol, and carbon dioxide. By the end of fermentation, DP1 and DP4 should be minimal, and ethanol should be maximized. This confirms that enzymes worked efficiently and yeast did its job. Using HPLC, we can get a real-time detailed progress report as we see in this chart. Slurry and FLT, high DP4 in early stages, and at FLT, the decrease in DP4 and increase in DP1, 2 and 3 value indicates breakdown. 4 to 6% in DP1 values after liquefaction is ideal for yeast health. Underfilling, DP2, DP3, DP4 are broken down and converted into DP1. DP1 sugars start being consumed by yeast, although it is still maintained between the range of 4 to 6% due to controlled glucoamylase dosage. Underreaction. Moderate dextrin remain with ethanol increasing. Fermentation in progress. Now final and POL. Residual DP4, DP3, DP2 and 1 sugar remaining. These are known as RS. Now we see that ethanol has been achieved. Since no negligible value is monitored to check as this gets recycled back into the liquefaction part. This graph shows the relationship between DP4, total sugars and ethanol across each process stage shown by HPLC. By analyzing how DP sugars and ethanol levels change from one stage to the next, we can detect exactly where the process is underperforming and troubleshoot it with clarity and confidence. You might have high glucose, DP1, in your final wash means problem in process parameters such as nutrients or contamination. High dextrin, DP2 and DP3 values are high. In your final wash, there is an issue in saccharification. High starch, residual starch in final wash, which means milling and liquefaction problem in your process. Traditional titration methods have an error of margin of 1 to 5%, which can mislead decision making, especially when troubleshooting fermentation losses. HPLC, on the other hand, deliver precise quantification with just 0.5% error, and more importantly, it tells you which sugars are left behind, starch, dextrins or glucose, so you can act accordingly. If your ethanol plant is producing more than 400 kiloliters per day, even a small efficiency gap can mean thousands of liters lost daily. Traditional tests can't tell you which sugars are left behind, but HPLC can. It shows whether your loss is due to unconverted starch, leftover glucose, or incomplete saccharification. That's the insight you need to take targeted action to protect your yield. And if you are not ready to install a system, start by sending us samples. We'll analyze them and guide you free of cost. Need help? Contact our technical experts at the Catalyst Group for sample collection. We'll analyze them via HPLC and send you a full interpretation, free of cost. Alternatively, we can help you install an on-site HPLC, and our team can visit your plant to perform a technical audit of your fermentation performance.